so suppose we wanted to combine these two fractions. So you remember how to do this. You don't really need to take a note, but we need a common denominator. So you would multiply the left fraction by x plus 1 over x plus 1, and you would multiply the right fraction by x minus 3 over x minus 3, and then you would get, I'm going to sort of skip a step, you would get 5x plus 5 plus 8x minus 24 over x minus 3, x plus 1. And that simplifies into 13x minus 19 over x minus 3, x plus 1. Okay? And you guys, you know that from 9th grade algebra or 10th grade, whenever you did these. They were very annoying because the teachers immediately did hard versions of them. So here's something we're going to do called partial fractions, the method of partial fractions, also known as partial fraction decomposition. Abbreviated PFD, which sounds vaguely obscene, but it's not. 13x minus, so now here's the thing. Suppose we started with this, and you wanted to figure out what were the two fractions that we originally had, the two rational expressions. So if I started with this, how do I get backwards to that? Okay? It looks scary, but it's really not that hard. Or it's not. You'll master it, because you're in 126. So what you do is you say, well, this must have been some a over x minus 3 plus some b over x plus 1. Then what do? We say, well, if I took this and I got a common denominator, I would know that it's a times x plus 1 plus b times x minus 3, and each of them is over x minus 3 times x plus 1. Alright? Remember, pretend I don't know what the answers are. So I got a common denominator. Multiply this by x plus 1, and multiply this by x minus 3. So that means that, now this is equal to 13x minus 19 over x minus 3, x plus 1. So that means that this must be the same as that, because of the common denominator. In other words, 13x minus 19 has to equal a times x plus 1 plus b times x minus 3. Make sense? Remember, I'm just working the other direction. Distribute. Remember, because they all have the same denominator, so I can ignore the denominator. The numerators must be equal. So I distribute and I get ax plus a plus bx minus 3b equals that. So far, so good? Alright, now, group the two x terms and the two constant terms. So I have 13x minus 19 is ax plus bx plus a minus 3b, or if I factor out the x, got that, right? Take your time. So again, what we did was we wrote this as a over x minus 3 plus b over x plus 1, and I got a common denominator by multiplying the top and bottom by x plus 1 and by x minus 3. And then I said since the numerator of this equals the numerator of this, then 13x minus 19 has to equal a times x plus 1 plus b times x minus 3. Then I distribute the a, distribute the b, and then I rearrange. I put the two x terms together and the two constant terms together and pull out the x. wait until people are caught up. Okay, so then, here's the thing that a lot of people have trouble with. Then a plus b must be 13, and a minus 3b must be minus 19. Why is that true? Well, this is something x, and this is something x, so they have to be the same. This is the constant, and this is the constant, so they have to be the same. Okay? There's no x in these terms, so they have nothing to do with the 13x. Does that make sense? Again, this is a plus b x plus a minus 3b. So since this is times x, it's got to equal 13. And since it's not times x, it has to equal minus 19. The two things are the same. Okay? Now I just have to solve this equation, which you remember with pain from algebra class. So let's see. If I subtract the bottom equation from the top equation, b minus minus 3b, I get 4b equals 32, b equals 8, which is kind of what we expected. And then a equals 5. So that means then that I now know, which I knew in advance, that this 13x minus 19 over x minus 3x plus 1 is the same as 5 over x minus 3 plus 8 over x plus 1. Okay? So I can work backwards just a lot more steps. And I can, when I start with a messy expression like this, I can figure out what the original expression must have been. So you say, that's nice, why would I care? Well, because I'm going to give you an integral like this. Okay, hey, I didn't invent the subject. You can go back in time, you can find Isaac Newton, what would you do? Exactly. Or Mr. Newton, he wouldn't last very long. Unfortunately, Leibniz also invented calculus, so take them both out. Just send Arnold Schwarzenegger back. So, in other words, if I had the integral of 13x minus 19 over x minus 3, x plus 1 dx, I now know that I could rewrite it as the integral of 5 over x minus 3 plus the integral of 8 over x plus 1. Okay. Well, this integral is just 5 natural log of x minus 3, and the other one is 8 natural log of x plus 1 plus c. In fact, to remind you, if you have the integral dx over ax plus b, that's going to equal the log of ax plus b divided by a. Or you could write 1 over a out front. It doesn't matter. Okay? Hang in there. Okay? So we're going to do 3 or 4 of these so you guys get the hang of it. Okay? Then we'll do the hard ones. I hate to tell you that. I don't think we're going to be able to get enough time in to do this all in 1 hour and 20-minute session, but I'll try. Okay? So we'll do another one as a team. Make sure everybody understands it. So, let's take a good example. That looks like a fun one. Okay. Okay, so let's suppose I have Alright, And the integral of 5x plus 1 on top, 2x squared minus x minus 1 on the bottom. So how will I know that I can do this with partial fractions? Well, what if I try u substitution? If I let u equal 2x squared minus x, du would be 4x minus 1. That's not going to, I'm not going to be able to turn that into 4x minus 1. So I can't do u substitution. I don't know what I would do with integration by parts. I could try sticking some trig stuff in there. That would probably be very entertaining. Right? Or I could say, aha, I remember this is integration partial fraction. That should be your first instinct if you see something with x's on top and something with one more power of x on the bottom. Okay? Or maybe two more powers. So first of all, since you love to factor, that factors into 2x plus 1 and x minus 1. I know you guys can all do that in your head. So that means that, forget the integral symbol for a minute, 5x plus 1 over 2x plus 1 times x minus 1 is sum a over 2x plus 1 plus sum b over x minus 1. Okay, so remember our technique. I'm going to get a common denominator. I'm going to multiply a by x minus 1, and multiply b by 2x plus 1. So it's going to be a times x minus 1 over 2x plus 1 x minus 1 plus b times 2x plus 1 over 2x plus 1 x minus 1. And then we can get rid of the denominators because they're all the same. And we just know that 5x plus 1 equals a times x minus 1 plus b times 2x plus 1. In fact, when you're at this step, the other way to think about it is clear the denominator. Multiply through by 2x plus 1 times x minus 1. And 5x plus 1 will equal a times this one plus b times that. So they sort of crisscross. Okay, they cross multiply. So you can sort of save yourself a step if you want. So you get to 5x plus 1 is a times what was under b, plus b times what was under a. Okay, distribute. Ax minus a plus 2bx plus b. Got that step? Distribute the A, distribute the B. What happens on April 13th? St. John's at 1 p.m. What day of the week is that? Wednesday. We don't like Oscar either. We hate Albany and Dickinson the most. I hope that's on video. How I feel about Albany and Dickinson. You'll be there? Albany's out of basketball, yeah. I wasn't sad to see that. Alright, so group the x terms, group the non-x terms. Okay? Yes? In other words, which one is A and which one is B? I mean, you could put A over x minus 1 and B over 2x plus 1. Sure, you can do that. Yeah, well, at some point, you'll end up in the same spot, but you'll get there in a roundabout way. Okay? There's no right way to divide it up. It doesn't matter. Okay. Then factor out the x. Okay? So now we know that a plus 2b equals 5, and minus a plus b equals 1. Because again, 5x, a plus 2bx, plus 1, plus minus a plus b. So the 5 has to equal the a plus 2b, and the 1 has to equal the minus a plus b. Okay? Alright, now I could solve this very easily. Just add those two equations together. The a's will drop out, and I get 3b equals 6, or b equals 2, and once b equals 2, a equals 1. This step seems to bother a lot of you. You get to here just fine, and then you can't figure out what a and b are. Okay? You gotta have to practice that. So that means that integral of 5x plus 1 over 2x squared minus x minus 1 dx is the integral of 1 over 2x plus 1 dx minus 2 over x minus 1 dx. Everybody can see that? So the first integral is the natural log of 2x plus 1 all over 2. And the second one is natural log of x minus 1 over 1 plus 6. So here the messy part is doing the partial fraction decomposition. The integration is easy. Okay? It's breaking the integral up that's hard. Hi, Paige. Go ahead. Why is it minus? It shouldn't be. It should be plus. Well, thank you to all 180 of you who didn't notice. Okay? It should be plus. Other questions? Okay, you get to come to the front and clean the erasers. Yes? Well, you take this equation, you add this equation. A minus A gives you 0. 2b plus b gives you 3b. And you add it. 5 plus 1 is 6. You guys ready for one? Yeah. Why is it divided by 2? You guys ready for one? I'll give you one to do on your own. Alright. We'll give you guys We'll just pretend we'll never talk about this again.
Yeah.
That's fine.
Got it?
Yeah, I just hate this part.
I used to teach her all this. I used to my brother.
I like that.
Yeah, I did. I put it in the front. I don't know. Which one you're watching? It's not that big. I put
You got to make it into one.
enough? For those of you who are watching this at home in the video, 8 minutes took place. Alright. Because these are the easy ones, then we're going to do the hard ones. Ready? So first let's factor this. Right? Okay. So this is A over x minus 2 plus B over x minus 3. So we know now that x minus 4 over x minus 2, x minus 3 is A multiplied top and bottom by x minus 3. Plus B times x minus 2. X minus 2, x minus 3. Okay? Yes? Doesn't matter which one you put under A and which one you put under B. Okay? Feel free to do either order. In the end, you'll end up with the same answer. Okay? Now, cancel those. And I know that x minus 4 is A times x minus 3 plus B times x minus 2. Distribute. I'm going to get x minus 4 is ax minus 3a plus bx minus 2b. Yes? Okay, Dan, what's the question? I just said that. It doesn't matter which one is over x minus 3 and which one's over x minus 2. As long as you factor it correctly. Okay? That's the hard part. Okay, so make that ax plus bx plus minus 3a minus 2b. So you have to do things like watch your minus signs and your grouping and all of that stuff. Factor out the a, the x, excuse me. Plus minus 3a minus 2b. And as I said before, then we get to the part where everybody has trouble, which is interesting. But I guess this is something that we just don't enforce enough when we're doing it in, 8th or 9th grade math. Okay? These are called systems of equations. So we have two equations. We have a plus b equals 1. And we have minus 3a minus 2b equals minus 4. So first of all, if minus 3a minus 2b is minus 4, then plus 3a plus 2b is plus 4. Okay? So you can ignore that. You can get rid of the minus sign. Now let's do this a different way, since people seem to have trouble with the subtracting equations. Let's say that b is 1 minus a and substitute, because many of you are more comfortable doing it that way. Okay? So this becomes 3a plus 2 times 1 minus a equals 4. Do they see what I'm doing? Who's lost? So once again, a plus b has to be 1, minus 3a minus 2b is minus 4, so plus 3a plus 2b is plus 4. And then since a plus b is 1, b is 1 minus a. So now I put it in for b, and I get 3a plus 2 minus 2a equals 4, or a equals 2. Okay? And since a equals 2, b is 1 minus a, so b is negative 1. Therefore, the integral of x minus 4 over x squared minus 5x plus 6 dx is integral of 2 over x minus 2 plus or minus the integral of dx over x minus 3. Okay? There's lots of steps. It's really not fun to grade this. So this is 2 natural log of x minus 2 minus natural log of x minus 3 plus a constant. A lot of these? Were any of you able to get this one? Wonderful! It is easier than some of the other stuff. Once you get the hang of it, the problem is just it's a lot of messy algebra. That's the problem with the whole course. Okay? Both differential and integral calculus is it's all the algebra that you hated back when you did that in high school. Right? Okay, now, of course, these are the easy ones. How do I make it harder? Suppose I have this integral. The problem is, x squared plus 9 does not factor. It doesn't factor over the reals. It's x plus 3i, x minus 3i. There's no imaginary numbers in this course. No complex numbers. So what do? Well, we still do partial fraction decomposition, but it's slightly more complicated. So, if you have a quadratic term that can't be reduced, you have to change what's in the denominator of you have to change what's in the numerator. So you still have an a over x minus 1, plus, now you have bx plus c over x squared plus 9. Why? Because it's going to work, okay? So, if this is x squared, you need a x term and a constant term. So bx plus c. If this was x cubed, you would need bx squared plus cx plus d. Okay? I mean, it can get really brutal, but we're not going to make it that hard. Okay? But we do test these. Okay? So again, because we have x squared plus 9, we have a bx plus c. That's necessary because when you do the decomposition, you could end up with an x term as well as a regular term. You'll see how this works. So let's get a common denominator. Equals, okay, a is going to be multiplied by x squared plus 9. It's getting kind of boring writing these denominators over and over again. Plus bx plus c times x minus 1 over x minus 1 times x squared plus 9. Okay? So again, the numerator is slightly different on one of the rational expressions. So throw out the denominators, and you get 10 equals a times x squared plus 9 plus bx plus c times x minus 1. And then we're going to have to do some algebra again. Okay. So distribute. You get 10 equals a x squared plus 9a plus, got a FOIL, bx squared minus bx plus cx minus c. And then do some grouping. So 10 is ax squared plus bx squared plus cx minus bx plus 9a minus c. And then factor. So you get 10 is x squared times a plus b plus x times c minus b plus 9a minus c. You loving these? Not so much. Okay. So, what do we know? What does a plus b have to equal? What does a plus b have to equal? Has to equal 0. There is no x squared term on the other side. So a plus b has to equal 0. C minus b also has to equal 0. And 9a minus c has to equal 10. So let's see. This says that a equals negative b. This says that c equals positive b. So let's substitute. We get minus 9b minus b equals 10. So minus 10b equals 10. b equals negative 1. You understand why a plus b has to be 0? You understand why c minus b has to be 0? Okay. We can make these harder. I took this equation, and I said a is negative b, so I put negative b in for a. And I said c is positive b, so I put b in for c. And I got minus 9b minus b equals 10. So b comes out negative 1, which means c is negative 1, and a is positive 1. We're not done, folks. So now, I'm going to erase this first line. I now have to find the integral of a, 1 over x minus 1 dx, right, plus integral of negative x minus 1 over x squared plus 9 dx. I'm not even close to done. Okay. So this first integral is easy. This is natural log of x minus 1. What about these other two integrals? Break it up. Make this the integral of minus x over x squared plus 9 dx, and the integral of minus 1 over x squared plus 9. Alright, how do we do that middle integral? U substitution. Yeah, I know. Like I said, try grading these. You have no sympathy because you're the ones who have to do it. Okay, well, the integral of x over x squared plus 9, let u equal x squared plus 9, du is 2x dx. So 1/2 du x dx. And this becomes, I'll slow down in a second, minus 1/2 du over u. This is minus 1/2 ln of x squared plus 9. Doesn't really need the absolute values. So we've done two of the integrals. First one is natural log of x minus 1. Second one is negative a half x squared plus 9. What about the integral of minus 1 over x squared plus 9? Any ideas? The minus is really very important. That's inverse tan of x over 3. The 3 comes from the square root of 9. That's right. Am I missing a third? Let's see, that's 1 over 1 plus x over 3 squared. And the third, 1. It's 1/3 tan inverse. Okay, so to help you memorize that, the integral of dx over x squared plus a squared is 1 over a tan inverse x over a plus c. Okay? I know. I don't test these because it's 400 steps. But I don't know if we're going to test them or not. We'll find out. Yes? Don't need to do the substitution on that one. What you would do is you would do a trig substitution. You would let x equal 3 tan theta. You probably wouldn't let x equal 3 tan theta, but that's what you would do. Okay? Yes? X squared plus a squared. So this is 3 squared. Okay? If that was x squared plus a, then it would be 1 over the square root of a. Okay? Let's practice one of these. Okay? I know this is hard. It's your first day doing it. Remember, the alphabet was hard when you were in first grade. And kindergarten. Oh. I hate these examples. Alright, I have to do a little erasing. We'll just erase this for the moment. Okay. Alright, that's going to keep you guys busy for a few minutes. I'm going to start erasing things. Well, let's speed it up. Or you don't have to memorize it. It's hard. It's important once you learn where the inputs come from, you should feel free to memorize them. Okay?
I think you're talking about right? That's a philosophy.
You should have fun, yeah. Do that in Astro.
About stuff.
Yeah, that's right.
Nobody ever asked like anybody else try?
We went to test camp.
What about Sophie?
Yeah, she's coming. And Sarah. Sarah, Jackie, both me. I do. I have a music. He's graduated.
Put this right there. Same thing.
I look like Stony Brook. Okay, I'll get one. I'll show you at the end. I don't like that. I swear. No, I do. Thank you.
Yes, you're talking to me.
I mean, Thursday. You saw me on Snapchat. You saw me Snapchat Thursday.
I did.
You're right. That was a fun Snapchat story to watch, isn't it? Whatever you want.
You should say that a problem like this has been other than that, obviously there's something like how do you think? But it's not it's why
Yeah,
So here we use substitution work.
Well, you break it into bits.
Break this one.
Alright. Height. I'm ready.
Oh, 4. Oh my god.
Alright, folks. Are we excited?
4,
Way too much fun. There we go. It's nice to have an X term in the denominator. That's a lot less work to do. Hope I copied this correctly. I did. Okay. So I know that 2x squared minus x plus 4 over x times x squared plus 4 is some a term over x plus bx plus c over x squared plus 4. And by the way, it could be ax plus b over x squared plus 4 and c over x. It doesn't really matter. Okay? In the end, you'll get the same answer. Alright. So I'm tired of writing that denominator step, but I know that 2x squared minus x plus 4 has to equal a times x squared plus 4 plus x times bx plus c. Everybody agree? Were we all able to get that step? Okay? That's by clearing the denominator. A gets multiplied by x squared plus 4, bx plus c gets multiplied by x, and then the numerator has to equal the numerator. So distribute. This has to equal a x squared plus 4a plus b x squared plus c x. And then you do a little grouping. So 2x squared minus x plus 4 is ax squared plus bx squared plus cx plus 4a. And then pull out x squared. And you get x squared times a plus b plus cx plus 4a. So I know that a plus b has to equal 2. I know that c has to equal negative 1. And I know that 4a has to equal 4. That worked out nicely. So we could give you a messier one that the numbers work out well. You get a is 1, and then if a is 1, b is 1. So now I know I can rewrite this as the integral of 1 over x plus the integral of x minus 1 over x squared plus 4. And I could break that into two integrals. So I have dx over x plus the integral of x dx over x squared plus 4 minus the integral of dx over x squared plus 4. So this integral is the log absolute value of x. This integral is going to need u substitutions. We'll do that in a second. And this integral is going to be 1/2 tan inverse of x over 2. Okay? Because you take the square root of 4, and it's 1 over that, tan inverse of x over that. Okay? That's the formula. Because x squared plus a squared. If a squared is 4, then a is 2. So far, so good? Now we just have to do the middle integral for the integral of x dx over x squared plus 4, do u substitution. Du is 2x dx, so 1/2 du is x dx. This is 1/2 integral of du over u, which is 1/2 ln of the absolute value of u, or 1/2 ln of x squared plus 4. You don't need the absolute value bars because x squared plus 4 is always positive. You can put them in if you want. They're just unnecessary. How much fun was this topic? Yeah? I can give you one more. We have time. Do we have time? Who votes for time? 1. You got a number. Gotta tell you. So the key to this is you have to break them up properly. Okay? And then do the algebra. So, I put some stuff up on Blackboard to help you from my book. And we'll see everybody on Wednesday.